Well, it was not only a very kind introduction, but probably longer than you're going to give me to talk to about Dr. Jacobs. Now, because I went around the room a little bit, and between the press people who have done their homework, or will do their homework after they listen to Paul, and the people in the technology industry that are here, I'm not going to talk to you about Paul's PhD, or his time at Berkeley, or how he's risen through and innovated, or even his 35-plus patents, because if I did that, Dwayne Roth would say, yeah, I've heard that introduction before. Move on, Darrel. But for Dwayne, who's here on behalf of UCSD Connect, and the others, I would like to take just a moment to have you understand that as a San Diegan, we have a treasure in Dr. Jacobs, and before that, Dr. Jacobs, which the insiders get. The fact is that San Diego is a innovation hub because of Linkabit and ultimately Qualcomm. It has spun out, spun off, and gathered and put together so many of what we are so proud of in San Diego. I sometimes say I give them credit for biotech, but they might object. But certainly in telecommunications and in the entire emerging ability to do anything, anywhere, anytime, and have all the information you need, Paul is, in fact, the innovator-in-chief. He is, in fact, not just the CEO of an S&P 500 company, but somebody who understands what the next generation will want, need, or he will provide, and they will grow to want and need. So when you, and then I'll close by saying, in addition to that, San Diego is a very big city with very few corporate headquarters. So unlike San Francisco or New York City or even Washington, D.C., we also, and it may embarrass you a little bit, but we also leverage Paul and his family to be, in fact, the leads on virtually every philanthropic activity that goes on in the city. Everything that gets done that's important to the community first says, are the Jacobs behind it? And in almost every case, they are. Now, as a proud Republican, I'd say I might be the exception. But the fact is that what Qualcomm does for San Diego makes San Diego what it is. So it was my pleasure to come over and do a short introduction for what I know will be a stimulating presentation. Thank you all.
Great. Well, thanks everybody for being here. I'm going to start off just by saying, how many of you have a 3G phone and know that you have a 3G phone? I do. I suspect most of you do. How many have a Verizon phone? Or an AT&T phone? Or essentially every cell phone that's out there now that's the third generation technology has Qualcomm technology inside it. And so as we're here to talk about mobile broadband and business models and kind of what's here in the future, maybe the best place to start is just the business model that created Qualcomm and mobile broadband as we implemented it. And essentially, it comes from ideas. We have employees, 16,000 employees around the world, about 14,000 in the U.S. We spent about $14.5 billion in research and development since the company was founded 25 years ago. We're celebrating our 25th anniversary this year. So basically what happens is those ideas turn into chips where we do the designs in San Diego, but we're what's called a fabless manufacturer, meaning that the chips are actually built in a factory, generally in Taiwan is where most of them are done. And then they're sent to manufacturers of devices. And for those 14,000 U.S. employees that are creating these designs, 94% of our revenues are actually generated offshore. So what that's done is through the licensing of the technology, two players in the wireless ecosystem, and the sales of those chips that go into the handsets. And ultimately, that money, those products, go to the subscribers through the operators. So we actually step a couple steps back from the end consumer, although we're always thinking about the end consumer, and we are selling to the handset manufacturers, who sell to the operators, who then sell to the end customer. That money then comes back into those companies and then flows back to Qualcomm and generates more and more R&D, more and more innovation. And hopefully you can think about the handset that you use today, and just think a few years ago, it was not very long ago, that things like the first camera phone came out. And now we think of that as an obvious thing, that your phone would have a camera with it. It wasn't so long that you got some internet access on your phone. We launched the first smartphone, for example, in 1998 with the Palm operating system. Now everybody with an iPhone knows that, hey, this is the way that you're going to get internet access in the future, and particularly for broad segments of the world, that's how they're going to get their access. And so, if we look out there in the wireless industry, we're getting a lot of forces that are aligning. We're getting the networks that are coming to bear, these high-speed networks. I'm going to talk about what's going on there. We're getting these incredible devices that have so much capability being built into them. And we're getting all of these applications, all this software, whether it's high-level operating systems or you hear about the apps that you can put on your phone. All of these kinds of things are coming together to really create almost a perfect storm of innovation and opportunity. And I think this is going to be an exciting time. It's already been an exciting ride for Qualcomm over the 25 years, but I think the next 25 are going to be equally exciting. Hopefully I can give you a sense of that excitement. Let me start off by saying one thing that I think is fundamental. There's 5 billion subscriptions to wireless services around the world. It is the largest platform in the history of mankind. 5 billion people can be reached. Qualcomm ships over 100 million chipsets every quarter. And I tell our employees that if you have an idea, you can literally change the world. You can change 100 million people's lives in the span of 3 months. It's an unbelievable opportunity to be in the middle of that kind of platform. And not only that, but over a billion people now have 3G. And what 3G gives you is not just voice and text of the 2G systems, but it also gives you mobile broadband. And so now you start to think about how we are going to impact people's lives when that device that they have in their hand is the device that gives them access to the internet and to other people, and not just by voice, but by data communications as well. And it's very interesting. In the second quarter of 2010, we added over 26 million 3G subscribers. So that growth rate is happening extremely quickly, to the point where if we look at it, there's going to be 2.8 billion people having both voice and mobile broadband in the palm of their hand by 2014. So now just imagine the opportunities that is going to create. It's really pretty amazing. And if we look in terms of broadband in general, mobile is dominating. So this line that's going up, it's a little bit purple on purple, I guess, or maybe it's a little hard to see. But essentially, if we look out to 2014, 75% of the total broadband subscribers will be mobile broadband subscribers. So that's pretty phenomenal. And we're expecting another 2 billion subscribers to be added between now and 2014, as I said. And of that, 90% of those mobile broadband subscribers are expected to be using the 3G technology that we created, that was created here. And also we spent a lot of effort with the Korean company, so I'm very happy to see the Korean ambassador here. We worked very much hand in hand and built this mobile broadband technology in the early days. So it's a pretty exciting task, but as I said, the opportunity in the future is incredible. And the other thing that's very interesting is it's not just about the high end. It's not just about the developed markets. 50% of these 3G sales now are expected to go to emerging markets. And so we think that the unit shipments are going to more than quadruple going into the emerging markets. It's about 39% annual growth rate between now and 2014. So huge, huge growth opportunity in the emerging markets. And there's a reason for that. I mean, having this connectivity is incredibly important. You can see the statistics here that if you increase mobile penetration by 10%, you get a 0.8% increase in GDP per capita if you have voice, But if you actually have mobile broadband as well, then it correlates to a roughly 1.4% increase in GDP per capita. And so if you look at the emerging markets, people in the emerging markets aren't necessarily going to have a PC. They're going to get on the internet through that device that's in their hand. And it really is the most affordable way to provide both voice and data access to a lot of markets. I can remember back when I was running a project to put fixed telephones into India, and we used the cellular technology. And back then, there was really not a lot of wireline infrastructure. We walked in and we took a device and put it down on the desk of the guy that was running the local telephone company and plugged it in and went to go. He said, what are you doing? I thought you were here to install a telephone. He said, well, we just did. So he picked up the phone, called his wife, she said it was the best call she had ever had, and we figured, okay, that was going to be good. We had won that battle. Now it took another, 15 years before we got 3G licenses in India, but hey, they're there now, so it's good. And I think that we're going to see tremendous growth out of India. Now, one of the things that we're doing with this technology is a program we call Wireless Reach, and there's, as you can see, 56 projects in 28 countries. And really what we're focused on is using 3G for social benefits, because if this is humankind's biggest platform, shame on us if we don't make good use of it. So we're doing things in health, in education, in entrepreneurship, in public safety, in e-government, all sorts of areas that you can imagine. Because wireless, today you think about wireless where you're talking from you to your friend, or you get on the internet or something like that. What's going to happen in the future is that wireless is becoming an enabling technology, that it will be embedded into a lot of things around you, and therefore we're going to have the opportunity to create a lot of interesting new services and give people in these emerging markets in particular access to stuff they didn't have before, better medical care, access to information on markets, and so forth. And so here's one example of this, an app we called Fisher Friend. And what had happened in Kerala in India was that there had been a tsunami, and a lot of the fishermen they hadn't had the warnings that the weather was going to change, and so there was obviously a catastrophe there that came from that. And so we worked together with a set of partners, local application developers, local wireless operators, NGOs, and put together an application that ran on a fairly low-end handset using the data capabilities and gave people advanced warning on weather conditions, but it also gave them information on where they could find the fish, and once they had caught the fish, gave them information on where they could take those fish to market so that not everybody was going to the same market and therefore depressing the price. And there was a study done on this exact system, and it showed that economic development in those areas had increased substantially. And this started out as a charitable project in some sense, and now it is a self-sustaining project. The application sells for 60 cents on the network of Tata, and so people have access to this, and they're getting value out of it. A very interesting opportunity. Another one where we've taken wireless and worked with Grameen Foundation, done a microfinance sort of business in a box for village phones, and so there are people in these various villages. They get a cell phone, and then they resell the service to people in the village. And as of February, there was 1,600 village phone operators. 100% of these village phone operators are profitable because it's a relatively low cost to get into the business. The average weekly profit, this number may shock you, is $3. Sounds like a very small amount of money, but it increased their household income by 20%. So it is a first step, obviously, to help people up the development ladder. And another thing that's interesting is 93% of these are run by women. 68% of them are living below the World Bank's definition of poverty, which is $2.50 a day. So really an interesting opportunity to introduce entrepreneurship using 3G technology. And another one that hopefully the ambassador has seen is one where we have family helpers. So this device that's in the middle of the picture is a device that has a camera in it and a microphone, and there's a set of helpers. There's 500 caregivers around Korea who interact with the elderly participants of this program so that people can see the person who's having the care given to them, and they can interact with them. And it's really changed these people's lives because now they have somebody they know is watching out for them, is checking in with them on a daily basis. And so they have this ability to dial up their helper if they need something, if something's happened to them. So it gives a level of connectivity that hadn't been there before. And these are just a few of the projects. As I said, there's a large number of these projects out there. So okay, so how are we doing this, and kind of what's going on, what's next? I mean, we know 3G is here, and we continue to drive the data rates up. More and more people can get on the network. We're trying to make the pipes bigger and bigger so that when you go to download your YouTube video on your phone, then you'll actually get to see it instead of having the data reception stall out a little bit. And obviously that's an issue because demand for data has grown so rapidly. But if you look at what's happened, it really has caught the industry almost by surprise in the sense of how quickly data traffic has grown. 2009, we saw that data traffic actually exceeded the voice traffic on the network. And AT&T was talking about 5,000% increases in their data traffic over a span of 3 years. So they saw that things were growing very, very rapidly. But guess what? It's not stopping at all. If we look out to 2014, the monthly traffic is going to exceed the yearly traffic. And my guess is that's probably an underestimate of what's going to happen in terms of data demand. I mean, it's terabytes of data that are getting sent over these networks. And so we expect that just to continue to grow. It's a great opportunity for Qualcomm as a company to continue to innovate, because this is the area that we really built the company around, was getting better and better systems put out there to give more access to data. In fact, we put the internet protocols into our system in the very early 90s, before the internet really became a big deal. And I think that's led us to think about data and the applications of data going forward. But so how are we going to fix this problem? It's a high-class problem to have a lot of demand, and there's a number of different ways. I mean, obviously, more spectrum is critical. We're doing things on the technology side. We're going to do things on how we roll out the data, but there's also other ways. We're going to use other technologies instead of just WWAN stands for wireless wide area networks, the cellular networks. In addition, we're using broadcast technology. So we actually bought Channel 55 in the United States. We broadcast video services over it, and in the future we'll also be able to broadcast data services over this technology. And many of you who have smartphones also know you go in, you offload your network to Wi-Fi. We'll also offload networks to local area networks, other kinds of local area networks, personal area networks, all sorts of ways to get that data in and out of the device so that you can have the service that you want at the right cost point as well, because that's obviously critical. And then the industry is looking beyond third generation to the fourth generation. And basically the idea of the fourth generation is that we use a certain amount of spectrum in the third generation. In the fourth generation, we just use more of it. And so obviously getting access to spectrum, as I said, is increasingly important. And as we see the rollouts, many of the rollouts will be this combination of third generation and fourth generation technologies together. Sometimes people will build out more heavily in the dense urban areas, because that's where the data demand is. In other cases, it will be built out nationwide. And so Qualcomm's spent a great deal of effort on fourth generation technology as well. Technology called LTE is probably our biggest R&D program in the company right now. And in fact, we went to India and spent $1 billion buying spectrum in a few key markets to ensure that this technology could roll out in India as well. So right now, there's a great amount of traction for this technology called LTE. There's 110 operators right now who are either trialing or committed to deploy, and that's been an increase from 64 operators 2 months ago. So the traction is growing very, very rapidly for this fourth generation technology. And as I said, it will be a combination of third and fourth generation and all these other technologies that we know about, Wi-Fi and broadcast and so forth. Okay, so that's the network. What about on the devices? We all know that the phone that we have in our pocket has sort of become this most personal device for not just communications, but for computing and entertainment and productivity and all of these things. And what that's meant is that we put more and more capabilities into the phone. So as I said earlier, we build the chipsets, we design the chipsets that go inside these phones, and we put all sorts of multimedia capabilities into it, put all sorts of graphics capabilities into it. Essentially any kind of thing you can think of a consumer electronics type device now sits inside your phone and gives you that functionality in one device. And that's not to say these other devices are going to go away. I'll talk about that in a second. But the other thing that happened, which is really interesting, so a few years ago, we noticed that in the technology industry, it used to be that you would invest on the high end, and features would trickle down to the low end. But then we started selling into the emerging markets. And what we found was to hit the kind of price points that you needed to hit in those markets, you had to spend as much money investing in the low end to integrate capabilities into the device to really lower the cost point down dramatically as you spend on the high end with the new features. So what's very interesting for markets like the United States, Europe, that I'd call middle markets, you actually see the features trickle into the middle as they get integrated into the chips that maybe came out of these low-end markets. Another really interesting thing that's happened out of the low-end markets is the investment that we've made to drive the cost down through putting all the components of the phone onto a single chip. Well, that's now enabling what we call machine-to-machine. So things like smart grid that I'll talk about in a second, other applications where you can embed wireless into other types of devices. It came back from the developing markets to the developed markets because of that really laser focus in on driving the cost down. The other thing that's very interesting that's happened on the high end is that you're starting to hear about gigahertz again. You remember when that was like the big story when you bought a PC, how many gigahertz you had? Well, now, guess what? That's come back whoop, that wasn't the right thing. Help me. There we go. Wrong button. So anyway, so that's now come back, and we have a technology called Snapdragon, and now the gigahertz wars are here again. We had the first 1 gigahertz chip. We announced a 1.2 gigahertz chip and a 1.5 gigahertz, and then 2 cores on the chip. And so just wait. I mean, you're going to have lots of fun with how many cores and how many gigahertz and all that other stuff you never thought you cared about back then. Well, it's coming again, so I apologize for that. But the focus, though, that's interesting here is that we're very, very focused on the low power, because even though you're doing all these things on your phone, you still want to be able to make a phone call at the end of the day. And so if we use up all the power that's in the phone on computing and consumer electronics functions, now all of a sudden you get to the end of the day and you say, oh, well, what happened to my battery? So low power is very critical. But you can see there's just a wide range of devices now that are getting enabled by this. Smartphones are obviously something that everybody knows about. iPad, people have heard about. That iPad doesn't have Snapdragon in it, but there are new devices that are coming out that are tablet devices, and they're going to come out in all different form factors, different sizes, large ones like the iPad, smaller ones that you can fit in your pocket like the Dell Streak, or obviously the standard smartphones as well. So very interesting thing. And one of the things that we see is that today it's about 1 out of every 5 phones, about 20% of the market is smartphones. By 2012, I think it's going to be basically a third of the market, and there are operators who are projecting going forward that half the market is going to be smartphones in the future. I mentioned power before. The other thing that we're doing to improve power consumption is on the display. So we actually invented a new display technology. It was started out of MIT. It was a startup company in San Francisco we bought about 7 years ago, and we spent the last 7 years really commercializing this technology. And what's interesting about this, I don't know how many of you have seen a Kindle or e-ink, but it's the same concept where you use the ambient light in the room to actually show the display. The difference is that this technology provides video and color. So it will be like a normal display that you have on your handset or any other kind of device, but it uses very, very little power. And it'll be viewable outside. So you know a lot of times you take your phone outside and you're trying to get directions or find something on the phone and it's too bright outside, you can't see it. In the future, you'll be able to see that. And another interesting point that I think will change the way you use your phones is that this is so low power, the display will stay on. So you know when you take your phone out of your pocket and you put it on the table, it looks like it's dead, even though it's on the network and it's doing stuff. In the future, that screen will be alive, and data will be coming into the phone, and things that you're interested in will show up on the front screen of the phone. So I think that's going to be a very interesting change to see how people react when the data that they're interested in can just show up to them at any time when they put their phone down. So what's going on now, as I said, is we're enabling new kinds of devices. We spent so much money in the industry on research and development, putting consumer electronics functions into the phone and computing into the phone. Now the phone is going out into other devices. So we know about things like e-readers and tablets. They're connected digital picture frames. The device on the far side is actually a game console for the developing market that's built around cell phone chips. So that's out there. We've embedded into a large number of notebooks, so that you get a notebook today, and many of them can be connected up to the network no matter where you are. So that's been a big success for us. So that's the hardware side. Now what about the software side? Well, we all know there's just a huge number of operating systems out there, and I recognize the fact that the Apple operating system's not on there, and it's not because I ignore Apple, but because we're not supporting them today. So they have our technology inside our phones, but we're basically supporting all of these other operating systems. Palm's on us. Windows Phone 7 is getting ready to launch. Is all on Qualcomm Snapdragon. Android, we were one of the earliest on Android. We support BlackBerry, but I'm sure a number of you have. And then Google's doing a new operating system, Chrome. And this is just a small smattering of the number of operating systems that are out there. But in fact, we launched the first Google Android phones based off of our chipsets. We launched the Nexus 1, which you might remember was Google's attempt to sell their own chipset. And today it's there's 50 launched designs based off of our chipsets on Google, and many coming to the market soon. And some of the most popular devices of this quarter now are based off of Android, based off of Qualcomm Snapdragon. So HTC Incredible, if you on Verizon, HTC Evo, if you're on Sprint, there's Sony Xperia, Lenovo's LaFon. I mean, it's just a broad range of devices that are out there being sold worldwide. Okay, so I kind of alluded to this when I started. I was talking about the notion that this is the biggest platform, but wireless technology, we believe, will be an enabling technology going forward that will transform many other industries. And what we see is it's really going to allow connectivity of everything to everything else. Now, not everything is going to be cellular technology. Not everything will be connected up with cellular technology, but it will be connected up via wireless technology, whether it's the lights, whether it's the projectors, whether the screens, the microphones, all the things around you and all the people around you will be connected through wireless technology. And it will be done both at a distance and it will be done when you're next to the person. So I might take my phone in the room and be able to see people here, and they might be able to share with me their social networking information, the things that they're willing to share. Or I might get in an accident and a first responder might be able to extract the information about my medical records through accessing my phone because I give them permission to access that phone because of the position that they're in. So all of these things are going to be connected. They're going to be connected both on devices that people are carrying around, and they're going to be connected on devices that are embedded into other machines. And so there's a huge opportunity for this machine-to-machine space. People are talking about 60 billion machines instead of 6 billion people. I think the numbers could be far higher. And I'll talk about some of the things that it's going to impact. It is absolutely going to impact education. Today, when a teacher thinks about a phone in a classroom, they think of that as a distraction. But what they need to think about it is providing personalized teaching, allowing the kids to actually participate with each other to help each other learn, giving them access to the net and to their teachers and to the curriculum on a 24/7 basis, to extend the school day when they want to have access to that kind of technology. And we already have a quote from the Secretary of Education. Most young people can't remember a time without the internet, but most learning experiences in school don't match that reality outside. We have to bridge that gap. Now that's just talking about the internet. I'm talking about the mobile internet. And before you think that I'm just making things up because I come from the mobile industry. We've actually done something. So this is another one of our wireless reach projects called Project Connect. And it was done with the North Carolina Department of Public Instruction, and we started it in 2007-2008 school year. And what we did was we took 150 ninth grade students, at-risk ninth grade students in rural North Carolina. We gave them smartphones with math curriculum on them. And what we found was the kids actually then interacted with each other so that the smartest kid in the class, he could help out the other kids, and really built a sense of community among the kids. What's very interesting about it, though, is the proficiency rates increased by 30%. And we know that because there was one class, same teacher, one class had the smartphones, other class didn't have the smartphones. So you could see the control versus the class that actually had them. And so we're actually expanding this program to more schools now, working with the Department of Defense Education Activity, and so money's going into this, and this is going to continue. And by the way, one of the things that we think that Mirasol Display will do a really good job for is giving kids textbooks, so that those kids aren't going to have to lug around 50-pound backpacks with them. They'll have that. They'll be online all the time, and they'll have the ability to have digital instruction. Another area that we think is going to have a huge impact is healthcare. Why? Because you have a device with you all the time, and that device that's with you can allow you to be monitored by your healthcare professional at all times. Not that they're going to be online with you all the time, but in fact they can check and see what's going on. And a critical area is chronic disease. 3/4 of the money spent in healthcare is on chronic disease management. A lot of that has to do with compliance with treatment regimes and just making sure that people are monitoring what's going on with them, with their condition. And so what we see is that wireless is going to really make healthcare more affordable. And as the population ages and the doctors age with them, we need to make our healthcare providers more productive, and we need to improve wellness among people. And having real-time monitoring is going to help that out. We know this already. We've had a project called CardioNet, which was a product that did cardiac arrhythmia monitoring hooked up to a wireless PDA. Clinical studies shown that it was 3 times more effective at finding problems with people's hearts. Why? Because they're out walking around instead of sitting in a hospital bed. Not to mention the fact that it freed up the hospital bed and it's much less expensive. So people are going to wear sensors on their bodies. There's a lot of work, a lot of innovation being done, particularly in San Diego, on this field of body-worn sensors. We're building radio technologies to connect these sensors up to cell phones. Now there's some regulatory issues that the FCC and FDA are working out about, is the cell phone then a medical device if it's connected to these sensors that might be used for treatment? And hopefully we can work that out. That's not an issue in other parts of the world, is an issue in the United States. But there's amazing things that can be done by being able to keep track. And as we talk to insurers, for example, about managing diabetics, they tell us that it's 10 to 15 times more expensive to take care of a diabetic patient who's lost control of their condition than it is for somebody who's managing their condition well. So there's really, really tremendous application for this. Some of these things that are real already. We've actually built these applications now on very sort of mid-tier kind of handsets. We're going to be doing some demonstration projects in India, in Egypt. It's very interesting. The emerging market wireless operators see this as an opportunity to provide services, healthcare services, to their customers. And so we're seeing a lot of traction around the world. And I think this will be another case where technology starts in the developing markets and comes back to the developed markets as well. So as I said, another exciting area. And smart grids is yet another thing. You can imagine now, with all these devices online, that you will be able to manage and monitor. And certainly, when we think about kind of the poster application, the killer application for smart grid in terms of electric vehicles, those things will need to be connected up. Because when I drive over to my friend's house for dinner and I plug my car in, they may say to me, I invited you over for dinner. I didn't think I was buying you a tank of gas or the electrical equivalent. But anyway, so there's a lot of work that's going on here as well. And the phone will actually be able to interact with these kinds of devices, manage your house, and so forth. Okay, so that's kind of where we are right now. That's what's going on in the industry right now. Sort of where are we heading into the future? And where we're heading, I think, is that because you have the phone with you and all wireless is going to be embedded into all the things around you, your phone's essentially going to act like a sixth sense for you to tell you what kinds of content and services are in the world around you. It will figure out the kinds of things that you're interested in and present those to you. And this kind of stuff is already starting to happen. I'm going to show you some early things that are going on. But it's very interesting because I think that we're going to see it become much more of a localized experience. And you do see some of this today using GPS technology, going into the network, coming back and giving you information. And when we first built GPS into the chip, people used to say to me, oh, this is great. I'm going to walk by McDonald's and they're going to send you a coupon. And I said, that is not going to happen because I don't want McDonald's to know where I am at all times to tell me when I walk by them to give me a coupon. In the future, with some of these new technologies, McDonald's would be able to broadcast a little signal out. And your phone, as you walk through, your phone would detect that. And if I have been going to McDonald's in the past, the phone would alert me, hey, there's an offer here for you. Now, McDonald's has no idea that I've received that until I actually take them up on it. So there's a nice privacy aspect to it, localizing these things. And it will actually provide a nice service. And you can imagine the extensions of this kind of notion to anything. As I talked about, the microphone might be telling me it has a microphone service, and the screen might be telling me it has a screen service. And all of these kinds of things around you might be telling you that here's the digital information or the digital service that's associated with them. Now, I know this may sound a little bit way out, but I'll tell you, when I started talking about the wireless internet 15 years ago, people were questioning that aspect too. They told me, I make phone calls on that thing. What are you talking about here? But I'm going to show you something that I think will at least hopefully capture your interest on this. So there's a couple of things that we're working on right now. How to give the real world a user interface with your phone. And it's this technology called augmented reality. Essentially use the camera and the screen of the phone and the touch screen of the phone to interact with the world around you. So you point it at various objects and things come up. And the first thing I'm going to show you is a system that we did with Mattel. Now you've heard about 3D TV. So this is a 3D technology as well, but it's really 3D because in the 3D TV you sit there and you just see one plane. With your phone, you can actually look around. So we're going to show you this Rock'em Sock'em Robot video, and it's a piece of paper on a table, and when you look at it with the phone, all of a sudden there's a game there, and you can imagine the extensions of that. So let me show you the video here.
Let's finish this. Here and now. No. Not here. Here. But where? I don't see anything. Oh, really? Look again. Oh! Hey, you set me up. I'm gonna knock your block off. What is this? It's Mattel. Of course. Mattel. Knocking the block off new technology.
So essentially those two phones are linked together. They're looking at a spot on the table and they're generating the same 3D graphics. And you actually, as you move the phone around, it actually changes the view and locks that 3D graphics to the same point on the table. So it looks like something's there in reality because you're looking around it, but it's not. You can actually, so it's a different way of doing three-dimensional, seeing three-dimensional objects. And so another use of this, though, is that we think that we're going to create these user interfaces for things in the world around you that don't necessarily have user interfaces to them. So the next thing I'm going to show you is how we use it to interact with the digital photo frame.
Okay, hello. I'm going to show how we're going to use a cell phone as a remote control to control consumer electronics and devices in the physical world. This is a regular Android, commercially available Android phone with a Qualcomm Snapdragon, and these are digital picture frames. I'm going to select some pictures from my catalog here. Just pick one of the dog there. And I'm going to share that, and I'm going to use augmented reality to select which picture frame that I'm going to do. And the camera is used as a sensor here. The camera and the phone and the picture frame are communicating using peer-to-peer technology. The natural features of the image on the frame can be conveyed to the camera. Camera's tracking it. I can select which picture frame an augmented reality kind of a purple bar there appears. So I'm going to show you right now how I'm just going to tap that. I'm going to interact with the physical world. I'm just going to tap that, and the picture goes right there. Okay, I can also take a picture right here live in this demo. I'll take a picture of the folks that are filming me right now. Okay, there we go. And now I'll use that picture as well, just to demonstrate that it's very flexible here. And I'm going to share that picture. Now again, using peer-to-peer, the picture frames are going to convey to me their natural features. That dog picture I just put up is now recognized. I can pick a different one here. I just tap it, and there it goes. There's the picture that I just took. So that's an example of using augmented reality, peer-to-peer technology, Snapdragon processor, Android, to control consumer electronics or other devices in the real world.
So the idea is that there was sort of a purple frame that glowed around the outside of the picture frame, and that was actually mapped to the frame itself. So when you moved around, it looked like it was stuck to the frame. So this notion of providing a user interface to devices in the real world that don't really have a user interface and giving you a simple way of interacting with them, we think that's another area where phones are going to be used in the future. And by the way, it might not just be for things, it might be giving a user interface to people as well. So having the ability to schedule meetings, get access to their Facebook information, those kinds of things. On an ad hoc basis, I might want to share information with you. All of these kinds of things are going to come about. Now they'll be because your device is willing to communicate to my device. So it's not that, it's not a big brother type thing. It's that your phone is broadcasting information that my phone then can listen to and then build the augmented reality around it. So to close, here in Washington, it's more and more critical as we talk about things like spectrum policy and innovation policy, and that the partnership between the government and industry has become increasingly important over time. And I think it's most obvious in the area of spectrum policy, but there are many other things. There's the issues of net neutrality and the question of whether that applies to wireless systems with their much more limited bandwidth. I think from our standpoint, we want to see the ability to have many different kinds of business models, not just a dumb pipe business model in the industry. Things like the Kindle, these ideas that we have for giving people in the middle of the market who maybe don't want to pay the full price for unlimited internet access, but they want to have access to the internet. All of these kinds of things, they need to be enabled, and we need to allow the innovation to occur. And we need to make sure that the innovation that's created, also the value can be generated from it, so that we can keep that cycle that I showed you early on continuing. So with that, I'd just like to say thanks, everybody. I think there's a ton of opportunity ahead, as I've said, in terms of mobile broadband. People think, oh, we're at the end, now we have these phones that do all of this stuff, what else can they do? I promise you there's plenty more that we have in mind, and hopefully there'll be things that will entertain you and delight you and your children going forward. So thanks very much for listening.